All right, let's look at the homework 4.6, problem number 5. All right, so this is a radioactive decay problem. All right, we want to find the half-life of a radioactive material if after 1 year, 99.67% of the initial amount remains, and we want to find the half-life. So let's do that. All right, so since we know that this is going to be an exponential decay, so since it's a radioactive, so I'm going to call it R of t. So this is the amount of radioactive material after t years. So it's going to be exponential, so it's going to be a initial amount we don't know, e to the negative kt, right? So knowing that after 1 year, you have 99.67% left. So write that in math notation. So after 1 year, this is going to be 0.9967, right? R0, right? So that's what we said. So it's a 99.67% of the original amount, which is R0. All right, but since using the formula, we can actually write the same thing. So T is 1. So this is the same thing as R0 e to the negative K and times 1. Since times 1 doesn't do anything, so this is it. All right, so what we can do is we can actually solve for, you can actually solve all the way to k, but I'm too lazy, so I'm going to actually solve for e to the negative k, because that's just going to be a constant, because there's no variable in there. All right, so let's divide through by R0, right? So then you have a 0.9967 is equal to e to the negative k. All right, so we know that we can plug this guy right here. So there's e to the negative k. So there's there. All right, so this equation becomes, maybe I'll write it down here. All right, R of t is equal to R0. All right, e to the negative k happens to be this particular number, 0.9967. And then we still have to raise it to the t power. So we have that. All right, so since we're looking for a half-life, so I'm going to set that equal to 1/2 of the original amount, R0. Then we can just solve for t. All right, so our first step is we can just, again, divide through by R0. So we get quantity 0.9967 raise it to the t power is equal to 1/2. All right, and since we have to isolate t, so it's an exponential function, so we take the natural log of both sides. So we put ln on both sides. All right. So what's good about this is that you can actually bring using the log property, we can bring t right in front of the natural log. So this is going to look like t times natural log of 0.9967, which is equal to natural log of 1/2. Right? Then we can solve for t by simply divide through by natural log of 0.9967. Right, so therefore t is isolated is natural log of 1/2 divided by natural log of 0.9967. All right, so I can't do this in my head, so I'm going to use Geogebra to compute it. All right, let's open up Geogebra, and we need to compute natural log of 1/2, just say 0.5, divide by natural log of 0.9967. All right, then hit enter. All right, and we want to round it to one decimal place, which it already is, so it's a 209.7. All right, so you have 209.7 years. All right, so let's type it in. All right, 209.7 years. All right, let's check the answer. All right, I came back and looks like we got this one correctly. All right, that's it. I hope that this was clear.